So today we will do a very important concept, Jahn-teller effect, after the name of the scientist. Jahn-teller effect in crystal field splitting, CFSCs, crystal field splitting energy. Any non-linear molecular system in orbitally degenerate electronic state, that is a state which represents more than one electronic arrangements of same energy, would be unstable, and that it would get stabilized by undergoing distortion in its geometry and thus by causing a split in its orbitally degenerate electronic state. So any non-linear कोई भी molecular system है, we know हमने अभी CFSC we have studied this theory in octahedral complexes, and we know how the electrons they arrange themselves in T2G and EG state, जो electronic state है. So any non-linear molecular system in orbitally degenerate electronic state, that state should have more than one arrangement which are of same energy. It would be unstable, and that it would get stabilized by undergoing distortion in its geometry and thus causing a split in its orbitally degenerate electronic state. It will be unstabilized, it will be unstable, and how it will stabilize itself, जो इसके electronically degenerate state है, उसमें there will be further splitting. The above statement, this statement is called as Jahn-teller effect, and the distortion in geometry of non-linear molecular system thus produced, and this effect is called as Jahn-teller distortion. This distortion is called as Jahn-teller distortion. Now I will give you example, it will be more clear then. Now let us consider an octahedral complex of copper ion with unidentate ligand L. There is a octahedral complex of copper which is let us say CuL6 kind of complex, and it copper ion is surrounded by unidentate ligand L negative. The copper ion is a perfect octahedral. Copper ion is in a perfect octahedral ligand environment, and it has ground state electronic configuration T2G6 Eg3, that we know. We have done, you know how to write the electronic configuration, and it represents two arrangements. Now there are possibly two arrangements, T2G6 Eg3. Now T2G6 means कि each dxy, dxz, dyz orbitals will have two electrons each. Now it is Eg3. When it is Eg3, it means that either dz square will have two electrons, or dx square minus y square will have one electron, or T2 or another possibility is that dz square will have one electron, and dx square minus y square it will have two electrons. So there are two possibilities, and both arrangements जो हैं, दोनों जो arrangements हैं उनकी जो energy होगी that will be equal, वो बराबर होगी. So now because of Jahn-teller effect, the octahedral geometry of the complex will be automatically lowered to tetragonal symmetry to stabilize the complex. Now what will happen due to the Jahn-teller effect, which we will study in detail further, the octahedral geometry, it will, in order to stabilize, हर एक जो आपका सिस्टम है उसकी एक टेंडेंसी होती है कि वो मैक्सिमम स्टेबिलिटी को गेन करना चाहता है. तो यहाँ क्या होगा, अपनी स्टेबिलिटी को गेन करने के लिए octahedral जो आपका कॉम्प्लेक्स है that will automatically lower its geometry to tetragonal. Now why this happens? T2G orbitals of copper ion in octahedral ligand environment are completely occupied in the ground state, that you know they are equal, उनकी energy same है, उनमें there is no issue, but the electronic charge density due to 6 T2G electrons will be uniformly distributed on all the directions. Yes, there is no problem in T2G, but the 3 electrons in EG orbital of octahedral copper 2 complex can be placed in two equivalent ways. Here there are two possibilities. In T2G there is no such problem, but in EG we have two arrangements possible. First is two electrons in dz square orbital and one electron in dx square minus y square orbital of copper ion. First is this, please pay attention. This is the first arrangement. In second arrangement, we will have two electrons in dx square minus y square orbital and one electron in dz square orbital of copper ion. Now we will go through the first case. Now we will go through the, pay attention to the first case. So in first case, the d electron density will become higher in z direction, obviously because both the electrons, we have placed both the electrons in z orbital, and screening of positive charge of copper nucleus by d electrons will therefore be more in z direction than in x or y direction. Obviously when both the electrons, they will occupy z orbital, so in z, along z axis there will be more screening of the this पॉजिटिव चार्ज. जो कॉपर पॉजिटिव 2 का जो न्यूक्लियस है उसकी ज्यादा स्क्रीनिंग z डायरेक्शन में होगी, क्योंकि वहां दो इलेक्ट्रॉन्स प्रेजेंट हैं z ऑर्बिटल्स में, एज कंपेयर टू x एंड y डायरेक्शन. The negative charge on the ligand L negative along z-axis will be less attracted by the nuclear charge on copper ion. Now, of course, this will happen because copper ion, the nucleus of the copper ion is already screened by the electrons, by the two electrons present along the present in the dz square orbital. And then the negative charge on ligand along xy directions. Consequently, the copper ligand attraction along z direction will be less. Yes, जो copper and ligand attraction, ligand got attracted. ligand जो है वो किस चीज पे अट्रैक्ट होता है, वो कॉपर के न्यूक्लियस की तरफ अट्रैक्ट हो रहा है, मगर अब वो कम, but it won't get attracted to that extent now because nucleus of the copper ion has been screened by two electrons along the z direction. Fine. And then but along xy direction, because in dx square minus y square orbital only one electron is present, so yes, the ligand that will get attracted along x and y direction. Because of this, the ligands along z direction will move away from the metal ion. Of course, the ligands, they will move away from the metal ion along z direction, क्योंकि वो less attraction फील कर रहे हैं, उनको अट्रैक्शन फील नहीं हो रही है स्क्रीनिंग इफेक्ट की वजह से. while ligands across x and y directions will now draw nearer to the metal ion, obviously because उसमें एक ही इलेक्ट्रॉन है एंड स्क्रीनिंग इफेक्ट जो है वो कम है x एंड y डायरेक्शन में, तो वहां पे क्या होगा, लिगेंड्स जो है वो कॉपर आयन के न्यूक्लियस की तरफ x और y डायरेक्शन में मूव करेंगे. In other words, the octahedral geometry of the complex will get distorted to tetragonal geometry. अब ये because of this unequal distribution of energy क्या होगा, जो आपकी जो splitting हो जाएगी further, EG के जो orbitals हैं उनमें ही splitting हो जाएगी, जहाँ पे there will be splitting, और क्या होगा, change हो जाएगी आपकी geometry, octahedral से tetragonal geometry में change हो जाएगी, which is elongated along z direction and compressed along x and y direction, because along x and y direction there is attraction, and along z direction, I will not say that यहाँ पे attraction नहीं है, but here there is no attraction, वो move करेंगे अवे, क्योंकि screening effect है, तो nucleus की तरफ the electrons, they are not getting attracted. So this is illustrated by this. You can see here, ये देखिए, along this z axis there will be elongation, and across x and y direction there will be compression. Distortion of octahedral geometry of Cu-L62 positive to tetragonal geometry due to Jahn-teller effect. Case 1 we have done here, and yes, this is the energy, and yes, you can see here these are the EG orbitals and they will further, ये अपने आप में ही split हो जाएंगे. the energy of dx square minus y square that will be more than that of the dz square. इसकी एनर्जी जो है वो कम हो जाएगी and there will be here the energy will be more. Now you can see here, due to elongation of metal ligand bonds along z direction, the electrostatic repulsion experienced by d electron of metal ion from negative charge on the ligands along the z direction becomes less. Very important. Obviously there is elongation due to this. तो ligands और जो आपका मेटल आयन है, मेटल आयन में भी इलेक्ट्रॉन्स हैं, लीगेंड्स का जो नेगेटिव चार्ज था और जो मेटल आयन में आपके इलेक्ट्रॉन्स हैं उनके बीच रिपल्शन होती है जो एनर्जी को डिटरमाइन करता है। पर अब इन दोनों के बीच डिस्टेंस बढ़ गया, इलॉन्गेशन हो गई है, तो क्या होगा, रिपल्शन घट जाएगी। व्हेन द रिपल्शन विल डिक्रीज, तो जो इसकी एनर्जी है ये डिक्रीज हो जाएगी आपके dz² जो ऑर्बिटल है। लेस देन द and across x and y direction what will happen, there is compression, ये मैंने आपको पहले ही बताया है। so the here across x और y direction में क्या होगा, जो आपकी repulsion है that will increase, वो बढ़ जाएगी। जो repulsion जब increase हो रही है means energy that will increase, so that is why. Now next we have, so I hope it is clear. The overall energy of split and unsplit orbitals remains same because please pay attention here to this statement. The overall energy of split and unsplit orbitals remains same because distortion of octahedral geometry to tetragonal geometry is automatic, that is without supply of energy from outside. So overall energy of the system, that is of the split and unsplit orbitals, that will remain same because it takes place on its own, because every system has a tendency to achieve the maximum stability. So we do not require energy from outside source here to achieve that stability. ये अपने आप से ही stability है, there is no energy supplied from outside. So overall energy of this, when there was split, when there was no split and when there is split, the overall energy remains same. जो अनस्प्लिट और स्प्लिट ऑर्बिटल्स की एनर्जी है वो सेम है रहेगी, इट विल रिमेन सेम, दैट इज वेरी इंपॉर्टेंट. Thus, if we assume that overall energy of unsplit dz square and dx square minus y square orbitals is 0, the energy of lower dz square, ये कब होता है लोअर, जब splitting हो जाती है, energy of lower dz square and higher dx square y minus y square after the split will also be equal to 0. This conclusion is expressed by the statement that the center of gravity of split orbitals is maintained, means total energy remains same, and this is known as center of gravity rule for energies of split orbitals relative to energies of unsplit orbitals. Now next we have case number 2. Now another possibility is that dx square minus y square orbital will have 2 electrons and dz square orbital has 1 electron. This is just the opposite of what we did. तो इसमें क्या होगा, elongation और compression जो है वो opposite होगा जो first case था उसके. The ligand negative charge, means the negative charge on the ligand along xy directions are less attracted by nuclear charge of copper ion. Obviously अब क्या होगा, अब x और y डायरेक्शन की तरफ जो है लीगेंड जो है वो कम अट्रैक्ट होंगे क्योंकि स्क्रीनिंग इफेक्ट है इलेक्ट्रॉन्स का. अब dx स्क्वायर माइनस y स्क्वायर में 2 इलेक्ट्रॉन्स है, तो क्या होगा, इस डायरेक्शन में जो अट्रैक्शन होनी चाहिए न्यूक्लियस और लीगेंड के बीच जो है वो कम हो जाएगी, अगेन ड्यू टू मोर स्क्रीनिंग इफेक्ट ऑफ लैटर बाय d electrons in x and y directions. This leads to elongation of metal ligand bond along xy direction and a contraction of metal ligand bond in z direction. You can see here there will be elongation. Why? Because dx स्क्वायर माइनस वाई स्क्वायर में 2 इलेक्ट्रॉन्स हैं, उनका स्क्रीनिंग इफेक्ट है, तो उस वजह से क्या होगा, ड्यू टू स्क्रीनिंग इफेक्ट द अट्रैक्शन बिटवीन द मेटल आयन एंड द इलेक्ट्रॉन्स दैट विल डिक्रीज, while across the z square orbital there is only one electron, so there is less screening effect. So there is attraction between the positive charge which is between the nucleus of the copper ion and the ligand, negative charge of the ligand. So across z axis there will be compression, and across this axis there will be x and y axis there will be elongation. Another thing which will happen is, obviously, when elongation, why the energy of dz square will increase here and that of dx square minus y square that will decrease here. Why this will happen? Again, due to repulsions. अब यहाँ पे elongation हो रही है, तो जो इलेक्ट्रॉन्स प्रेजेंट है कॉपर में और जो लीगेंड के नेगेटिव चार्ज है उनके बीच जो रिपल्शंस हैं वो घट जाएंगी, और यहाँ पे क्या है, जो d में इलेक्ट्रॉन्स हैं प्रेजेंट और जो z आपका ऑर्बिटल है उनके बीच क्या है, यहाँ पे कंप्रेशन हो रहा है, तो इनके बीच जो रिपल्शंस है ना इलेक्ट्रॉन्स के बीच दैट विल इंक्रीज. जब रिपल्शंस बढ़ती हैं तो व्हाट विल हैपन, the energy of dz square will increase and that of dx square minus y square will decrease. So this is the consequence of Jahn-teller effect, and this is the reason why you have studied this pattern also. This is the reason why the geometry gets distorted from octahedral to tetragonal. Further we will do in the next lecture. Thank you.